Most languages today are object-oriented, and we use object-oriented programming methodologies in creating our applications. Python is an object-oriented programming language, and we've actually been doing some object-oriented programming all along, but we haven't created our own classes, which is what we're going to talk about when we get into this idea of object-oriented programming methodologies. Data consists of objects, and we've created objects all along, being string objects, integer objects, floating objects. Those are our data, and every time we create a variable, we're creating a data object that we can interact with. So data consists of objects in object-oriented programming languages, and each item of data is referred to as an instance. Those instances are built around a design structure that we define as a class. So as we move forward now from what we've been doing more of traditional programming methodologies into this object-oriented viewpoint, we're going to be creating our own classes to contain or create different objects of that type of class. Each class defines properties, and depending on the language, that might be referred to as attributes or fields or class-level variables. Classes also define methods, and those are the things that a class instance can do, or maybe the values returned upon calling a method in a class. Some classes aren't necessarily used for data objects as much as they are used for a collection of various types of methods that can be referenced. The random class we've been using already is a great example of that. In terms of data objects, though, one method you'll encounter is a constructor, which is used to create instances of that class. In Python, we refer to it as initializers. And then we might also have events. Those are triggers for those different methods, primarily in a GUI or graphical user interface environment. So we can think of classes as the design or the blueprint. Looking at an automobile as an object, we'd all refer to an auto or a car as an object, just like a pen is an object, or a calendar is an object. So let's take the car as an object. There are engineers who design the specifications of those cars, both in terms of their appearance, in terms of how they function, how they work. But then those specifications are taken to the plant and used to create instances of those cars. These are the actual objects being created from the class specifications. And in an auto industry, that's something physical. In our case, it's going to be something data-oriented. But each of those objects might have some variances in them based on the different properties or attributes. So here we see a bunch of Fiat 1100D automobiles being created on the assembly line in 1963, I think these are. And notice that there's different colors, but they're all Fiat 1100Ds. They're the same car, but each instance might vary from another because the properties can vary. In designing a class, our custom class, we use what's called a unified modeling language diagram. And there are various UML diagrams. This one is for a class designation, in which the name of the class goes at the top, and then you see some boxes below that. The first box is the properties or attributes. So our cars are going to have an exterior color. They might have an interior color. They'll have a retail price and a dealer cost. Those properties can have scope. So you'll see a plus sign to the left of exterior color, interior color, and retail price. Those are what we call as public scope. Another program can access those. If we were to go buy a car, you and I can see what the exterior and interior colors are. We can look at a window sticker and see the retail price. But what's hidden from us is the dealer cost. We don't know what the dealer paid for that, or what it cost to build that automobile. That would be a private property or private attribute. The next box are methods. These are things the car does or values we can get from our car instance. So we can start the engine. We can get gallons in the tank. How full is the tank? How empty is it? We can add gas to the tank. We can press the horn and have it honk. But one thing we might not be able to do, unless we're a trained professional, is adjust the engine timing. That might be a private method that we don't have access to. And of course we have other public methods such as being able to turn left or right. So this diagram is used by the systems analyst to provide to the programmer to develop this class, this custom class, with these appropriate methods and attributes. We talk about the 4 pillars of object-oriented programming, being encapsulation, inheritance, polymorphism, and abstraction. And we'll go through each one of these individually. Let's talk a little bit about encapsulation. So encapsulation is the idea that some details are hidden from us. We don't need to know how things necessarily work. We don't need to be able to access that detailed code. We simply oftentimes need to send a parameter and get some returned results. So in the case of a car, when we turn the key, the engine starts. And so we can specify this method of turn key, and the result that comes out is the engine starting up. We don't necessarily know how the combustible engine works, or do we need to know that? We just know that we turn the key, the car starts. So that black box of how the combustible engine works and everything that happens in that process from the time we turn the key to the time that our car is rumbling along is what we call encapsulation. Those details are hidden from us. Same thing, data might be hidden from us. Let's say we have some data about an employee, and one of those things might include the employee's salary. Now for some, that may not be accessible. We might be unauthorized to view that employee's salary. But somebody else might be authorized. The person who's unauthorized who tries to get that will get a message saying simply, you're not authorized to view that. But somebody who is authorized, maybe our accountant, can see that information. This is going to come into play in our classes in that something that's private can only be accessible from within that particular class. Maybe another method needs to use the value from a second method, and that second method's only available to the method calling it in the class, but not from outside of the class. This can help with security. Inheritance is the idea that we have classes that are related to one another. So let's say our car class is a child of an automobile class. We have parents and we have children. The automobile class contains properties and methods that would be part of all automobiles. Every automobile is going to have an exterior color. There'll be a value for the number of doors. There might be a value for the number of valves in the engine. Every automobile has an engine that can be started. That's a method. It has an ability to brake, and of course a whole lot more. Then we can create a car class that inherits from the automobile class. That car class would inherit all those properties and all those methods. But there are some things unique to a car that may not be true of all automobiles. Not all automobiles have a trunk. And so the car might have a property of the trunk capacity. What's the square footage of that trunk? A car might be convertible. So we might have a Boolean value that says, yes, that car has a convertible roof. There are methods that are associated with cars that may not be associated with other objects such as a truck. And that is the ability to open the trunk or close the trunk. Might be the ability to open a sunroof if your car has that sunroof. A truck, on the other hand, is also an automobile. While it inherits all the same properties and methods from the automobile, it does have some unique things to it. A truck has a bed length. And it also has a towing capacity. Not that a car couldn't tow, but we think of trucks as having towing capacity. A truck might be four-wheel drive. A method of the truck might be to pull a trailer. So that's inheritance in a nutshell. We have classes inheriting from a superclass. So the car and truck could be called a child or a subclass. The automobile would be called a parent class or a superclass. Polymorphism is having the same methods but with different implementations. And what I mean by different implementations is the parameters that are sent to that method will vary. And they vary in terms of the number of items sent, or they might vary in the types of items sent. So let's say in our automobile we have two methods called add gas. The methods are called the same thing, but one takes a Boolean value, and that Boolean value tells the car to be filled with gas. In that case, what happens in that method is it might determine how large the tank is, how much gas there currently is, and add the appropriate number of gallons to the tank to fill it. Whereas in the add gas, we're specifying the number of gallons to add to the tank, and that's a float value. The two methods behave a little bit differently, but they're named the same. That is polymorphism. In this case, this is a particular form of polymorphism called overloading. It might be a situation where we have a method in the car class that is the same name as a method in the truck class. Or it could be a method in the car class that overrides a method from the automobile class. Those would be additional examples of polymorphism. And then abstraction kind of takes in the whole idea of inheritance and polymorphism, wraps those together in a methodology called abstraction, in which we specify a method in the superclass or the parent class that is not implemented. It's just simply named there. In this case, we might have load luggage. And in abstraction, then, we're required to create that load luggage method and implement it in each of the child classes or the subclasses. So in load luggage in a car, the methodology for that might be different than loading luggage in a truck. In a car, loading luggage probably means putting it into the trunk of the car. Could be putting it on top of the roof. In the truck, that might mean loading the luggage into the bed of the truck. The method call is basically the same, but what it does and how it operates is different in each of those subclasses. So it's polymorphism, but we specify from the value of inheritance, those classes have to inherit that abstract method that's declared in automobile. That is abstraction. We've actually been using object-oriented programming all along in this class in Python. So the next video, we'll talk a little bit about how we've been using object-oriented programming and now how we're making the shift to declare our own classes. If you just jumped into this video and haven't seen the prior videos to this, I invite you to check out my Python playlist of videos. And if you'd like to be alerted to future videos that I create, you can click my picture up in the top right and subscribe to the channel.